Thank you. My name is Søren. I am an engineer and I hold a PhD in sustainable energy technologies. As all of you probably know, we're in the middle of a transition or maybe even a revolution of the energy systems in at least the northern part of Europe, but all over the world. In Denmark, we're doing that by setting up wind turbines like there was actually a tomorrow and like we actually cared about it. The reason why we chose wind turbines in Denmark is that we don't have a whole lot of sun here, as you probably know. We don't have any mountains, so we don't have hydropower, and we don't have any sort of experience with nuclear power, not a lot at least. So we chose wind because we're good at wind and we have a lot of it. So, as you perhaps know, renewable energy sources are intermittent. That means that electricity is produced in wind turbines when the wind blows. It is not produced when there is no wind or if there is too much wind. This does not mean that renewable energy sources are flexible because we can't control them. So they produce whenever they want to and not when we want them to produce all the time at least. That poses some challenges. And so this graph shows this intermittency of wind production. You have energy production out here on the vertical axis, and then you have some days. And what you see here is 3 weeks, so each peak in the red curve is 1 day. The red curve is the demand for power in Denmark, and the blue curve behind it is wind production or electricity production from wind in a system where we have 50% coverage in the electricity system from wind. Now, right now we have 40, so this is in 5 or 6 years. As you can see, in some days we produce too much electricity from wind, and in some days we produce too little. That is the challenge, and I'm going to talk about 5 possible solutions, so I'll be in a bit of a hurry here. The first solution is not a solution. You have probably heard this mainly from right-wing politicians. We need nuclear power in order to solve this problem. This is not true, and the reason why this is not true is that nuclear power is essentially the same type of power production as wind. That sounds strange, but the reason is that nuclear power is not flexible. Nuclear power produces the same amount of power all the time, and if we want that to change just a little bit, we have a very large thermal mass in the nuclear power plants that we need to heat up in order to produce more. It's the same with coal-fired power plants, and this means that we cannot supply the electricity that we need in times of too little wind production with nuclear power. So this is not a solution, and now it's out there. 4 other solutions though. Solution 1 is distribution of electricity production. As you may know, we have wind turbines all over Denmark, but we have the most along the western coast, and that is because that is where we have the most wind. We do, however, have large wind farms at Anholt down here, and we're building a new one at Kriegers Flak here, in less than optimal positions. And the reason for that is that the wind doesn't blow with the same speed all over Denmark at the same time. Also, when a storm hits the western coast, all the wind turbines out there shut down due to safety reasons. When that happens, we still have wind turbines in the rest of the country that are running. So when the storm passes the country from west to east, as the storm hits the easternmost wind turbines, the ones at the west coast will be ramping up again. So this makes for a more stable production of wind. And that's clever. We do the same with solar. We distribute it all over the country so that when there is no sun in the northern part of Jutland, the sun might shine in Copenhagen. That was for distribution. The next thing is storage. We might just be able to store all this electricity, right? You've probably heard about this. Yeah, that's kind of a problem. You may have heard about the Tesla Powerwall. That's some batteries that Tesla launched something like half a year ago. Changing the energy landscape, Powerwall will take homes and businesses off the grid. Yeah, but the problem is we don't want homes and businesses off the grid. We want them to be on the grid, at least in Denmark and northern European countries, because our grids are very good, and we have a very high security of supply in Denmark. So we need people to be on the grid to keep this high level of supply security. And by the way, what's wrong with Norway? Norway have a whole lot of hydropower, and hydropower is an excellent and very cheap battery. So what happens is when the wind blows a lot in Denmark, we sell our electricity very cheaply to Norway. They stop the dams and consume our electricity. When the wind stops in Denmark, they open the dams, they start producing very cheap electricity, and they sell it back to us at a kind of a high price. And you're laughing, and most people say that, yeah, this is the Norwegians laughing at us again, but that's actually not true. The Norwegians have a capacity for storage that we don't. And the difference between what we get when we sell electricity and what we pay when we get it back, that's the price of storage of electricity. So we're just paying for a service. And this service is orders of magnitude cheaper than this service. So going for Tesla batteries, that is when someone will be laughing at us. This is just the Norwegians smiling because they happen to have mountains. Okay, also, this is just a chart showing all the lines or power cables that we have to our neighboring countries. The green ones are being planned. A few years ago, some scientists calculated that if you took a copper plate, the size and shape of Europe, and put it on top of Europe, we could solve the energy problem. This means that if we could just transport energy from where it's produced to where it's needed with no losses, we don't have any, or the storage problem is solved. Of course, we can't do that. Copper plates that size are impractical. But what we can do is that we can multiply our transmission capacity tenfold. That should be possible, right? I mean, 10 is not that large a number. If we do that, we've solved the problem also. Then the scientists said, well, that's probably not that possible, so let's say 5-fold, and then we've solved half of the problem. But that means that just by putting up more cables, we can actually solve half of this problem, and then all of Europe can run on sustainable electricity. So that's a very large part of the solution, and it requires countries like Norway, but that's okay. We like the Norwegians. Okay, so for flexibility, that's the third solution. We can have flexible production, and we can have flexible consumption. Flexible production is something that we are very good at in Denmark. The reason is that we have a district heating network. In the district heating network, we have gas engines and gas turbines. They run on natural gas, and they produce electricity and heat whenever electricity or heat is needed. We have a lot of these, and they are in these weird sci-fi-ish looking structures all over the country. They are district heating plants. Those gas engines can start up in minutes, so whenever wind turbines shut down, they will start up and produce the electricity that we need. This is our flexibility in Denmark, and we are very good at this because we have a hell of a lot of these gas engines sitting out there. Now you could say, well, natural gas, that's being phased out. It is, but we also have a lot of biogas because we have a lot of pigs in Denmark. So in the future, when we start producing all this biogas, we can run biogas through these gas engines, and that can actually solve most of this problem also. Of course, we could also have flexible consumption, and you may have heard of this. We could charge our electrical vehicles overnight, we could do our laundry overnight, but the real problem here is that electricity is cool because it's there when we need it, right? That's what we're used to. If we all of a sudden have to start spending electricity at times where we don't think we need it, or we need to wait spending electricity, that may not be that good an idea. And also, doing our laundry and refrigeration and stuff overnight will move maybe 1% of what we need. So that will not solve the problem in itself. But of course, I mean, it's a small part of the solution. The fourth and last solution is called integration. What we can do is that we can integrate the 3 energy grids in Denmark. One is the electricity grid, that's power. We can integrate that with the heating system so that in times of cheap electricity, we can use a heat pump like the one in the picture, or an electric boiler to produce heat. And we can store that in the heating system. This is not really electricity storage because the heat will not turn back into electricity. So this is more like flexible consumption, just on a very large scale compared to those laundry machines. And the final, and these heat pumps are sort of being set up around now or maybe in a few years, but it's happening now, and the technology is there, and it's, by the way, Danish technology. We're world leaders in heat pump technology. The final thing I want to mention is power-to-gas technologies. That's a bit sci-fi-ish. We can spend electricity to produce hydrogen gas or natural gas. We can store that in the natural gas grid. That's a very large system of pipes and very large storage tanks that we have in Denmark. And it turns out that all of that energy that we want to store from some point in time to another point in time from the electricity can actually fit into our natural gas system over a year. And this means that when we get these technologies, they're called electrolysis, when they're ready, and they will be in, this is a bit dangerous of course, but let's say 5 to 20 years, maybe 10. When they are ready, we can solve this problem also by producing gas and storing it in the system. So as you've heard here, we have a lot of solutions to this problem. We don't need nuclear, we don't need batteries, we don't need solar roadways or any other weird things that are out there. We need technologies that we already have or technologies that we are developing in Denmark right now and are very good at developing. So we're going to be okay.